the introduction and for the invitation. I'm really happy to be here today to present you. All right. I'm really happy to present you today the Passivhaus as a solution for the NZEB, as well as introduce you to the new Passivhaus classes, PHPP9 and Design PH. So, as João said, from 2021, all new buildings should be nearly zero energy buildings. And this definition is open to each member state. But what is sure is that this building should be very high energy efficient, it should also be cost optimal, and that its demand should be covered by renewable energy to a very significant extent. So in the following slide, I'm gonna show you that the Passivhaus is meeting all those criteria. So the first criteria about energy efficiency, a Passivhaus is energy efficient by definition, because to be certified it needs to have a heating and cooling demand that is smaller than 15 kilowatt-hour per square meter a year. And its energy demand, primary energy demand, should be limited to 120 kilowatt-hour per square meter a year. So when we are looking at this graph, where you can see the energy demand of an existing building, low energy house and Passivhaus, compared to an existing building, this means around 85–90% savings. And this has already been proven for thousands of buildings. Regarding cost optimum, usually when you're investing, when you're buying a high energy, highly performing house, you need to invest more at the beginning, like you can see on this orange curve. The yellow curve is showing you the annual energy cost, which is rising with your energy demand. And when you're adding up those two curves, you get the total life cycle cost. And you can see in this curve there is a drop, whereas the building is, thanks to its higher energy efficiency, it's cost optimal, because you can do away with some parts of the service components. And this is exactly the approach of the Passivhaus, because when we have a heating and cooling demand that is smaller than 15 kilowatt-hour per square meter a year, we can heat and cool our building via the supply air. Another interesting graph about cost optimability. This one is showing you the additional cost of a Passivhaus tenants over the first years in Germany. As you can see, the first Passivhaus was fairly expensive, but the second Passivhaus was already half cheaper because people have had more experience and they knew which expensive components they wouldn't need, which component wouldn't have a significant impact on the energy balance. And for the third project, Passivhaus quality windows were already available, so this also made the cost drops. And moreover, there was also a research group for cost-efficient Passivhaus that were created at this moment, which also helped to drop the cost. So, as you can see, the learning curve and the component availability has a great impact on the investment cost of a Passivhaus. But it's important to keep in mind that the investment cost of your Passivhaus will mostly depend on its design and on the location as well. Like in Portugal, you're in a so-called happy climate, where it's easier to reach the Passivhaus standard than, for instance, in Germany. And to the last point of the directive, it's about renewable. The Passivhaus can be easily supplied with renewable because it has such a low energy demand compared to existing buildings. And some example, like this one on the top of the slide, is supplied with PV panels. And other examples are supplied with wind turbines that are nearby. Like this is agreed in the directive definition that the renewable energy can be produced on-site or nearby. So to sum it up, the Passivhaus and renewables met all the requirements of the NZEB. It's tried and tested. And moreover, the main advantages of the passive house is that it has clearly defined criteria which are based on physical laws which apply internationally. Moreover, we have now 25 years of experience. Like the first passive house, Kranichstein, which was built 25 years ago, is still consuming 12 kilowatt-hour per square meter a year for heating. And the passive house standard is suitable for all usage types all over the world for both new buildings and retrofits. Now, not everybody thinks that NZEB is necessarily a passive house, because it's mainly depend how they are dealing with energy production and renewable energy generation. Because some people allow their building to consume more energy, but then they're asking for the building to also generate more renewable energy. But we can wonder if it is really as simple as this, if we can just balance out a higher energy consumption with a higher energy production one-to-one. And to answer this question, I will introduce you to the PER factor, primary energy renewables, and to the new passive house classes. So quickly about the context. Until now, we have been mostly using fossil fuels, which are causing several problems, like they are not available in unlimited quantities, and are also causing a lot of pollution of CO2 emissions, as well as radioactive waste. But fortunately, we are now transitioning towards a world where the supply is relied through renewable sources. And this is why the Passive House Institute thinks that the current assessment, which is based on the primary energy factor, is not suitable anymore, because it's focusing on non-renewable energy. And it's considering renewable energy as a freebie with no negative factors, when this is not true, because renewable energy is not available in unlimited quantity. And we also have to consider the losses through the storage, as well as the impact in the landscape and the cost. So this is why the Passive House has introduced the new PER factors, and those factors are based on the scenario that in the future the supply will be realized only through renewable energy. We are not quite there yet, and it will happen faster in some countries and slower in other countries, but it is important to keep in mind that buildings have a long lifespan, so we should design them for the future and not optimize them for the current scenario. So to explain you how the PER factors are calculated, I'm going to take an example. It's a passive house in Germany in winter. This is its load profile for 1 week. It's taking into account the heating load, the domestic electricity, as well as the warm water load. And this energy demand can be supplied through hydro electricity, wind electricity, and a bit through PV electricity, because in winter there is much overcast and the sun is not as bright as in summer. So as you can see, the demand is sometimes met, but most of the time we have an energy shortage in red. We can fill a bit of this energy shortage with the bit of energy excess at the beginning of the week, but clearly we still need more energy, renewable energy. Now it's summer again in Germany, and you can see that the load profile is already a bit lower because we don't have the heating load anymore. So again, this demand can be supplied by a bit of hydroelectricity, but mostly through wind and PV electricity. Now this time the demand is almost always met. There are some shortage, but we can easily fill it with the energy excess if we store it in short-term storage. And there's even so much excess that we could keep this excess and use it in the winter again if we store it in long-term storage. And so I'm going to talk now about storage, because storage means losses. So at the beginning you have primary electricity renewable, so mostly sun, wind turbine and hydroelectricity power. A part of the electricity that is generated can be directly used in your passive house, when the demand and the supply happen at the same time. When there is an energy excess, this energy excess can be first fed into the short-term storage. And when we need it again, the short-term storage like batteries, for instance, when you can store your energy for a couple of hours or a couple of days. And when you need this energy again, then you release it again, but this occurs around 30% of losses. Now, if you still have some excess, like in the summer, you can store this energy into long-term storage, such as chemical storage, like transforming electricity into gas. And when you need it again in winter, then you release it. And here you see we have a big losses. Around 70% of the energy gets lost. And now you probably better understand why it is really important to lower your heating demand. Because for the heating demand you need to use long-term storage. And now I'm going to show you the PR factors. So basically it is the ratio between renewable energy generation and final energy demand. Which means that if you need 1 unit of energy for your passive house and you have a factor of 1.5, then you need to generate 1.5 units of renewable energy at the beginning. So basically the PER factors are defined by the concurrence of generation and demand, and then depend on the location, because each location has a different percentage of renewable sources. Like you can see in Abu Dhabi, there is no hydroelectric power. The PR factor also depends on the use, because each use has a different load profile. And basically the heating load in European climates, mid-European climates, the heating load will be higher than the energy generation in winter, but the cooling load will be lower than the energy generation in summer, which means that the PER factor for heating will be higher than the one for cooling, because it will involve more storage losses. So now this is a graph for Portugal. We can see that Portugal has 30% of hydropower potential, which is great because hydropower is available throughout the year constantly. You also have quite a lot of wind turbine and PV potential, but as you can see, in winter there are still some gaps. So you will still need some long-term storage for winter. This is why you will have a heating PR factor for Porto around 1.65, whereas for cooling it will be lower, because you have more energy available during the summer. Now here I come to the new passive house classes, which are based on these PR factors. So basically the classic is the passive house as you've always known it. The criteria stay the same. It's still respecting the 15 kWh per square meter and yeah, the air tightness, everything. But it doesn't generate some renewable energy. And the new really classes that we have introduced are the Plus and the Premium. Both are passive houses as to the standard definition, but in addition to that, they also have a higher energy efficiency and they're generating renewable energy. So as you can see, on one hand you have the efficiency level of your house, or so to say the total PER demand, which goes from 60 down to 30. And on the other hand, for the Plus and Premium, we're asking for energy generation, be it on-site or nearby, that goes from 60 to 120 kWh per square meter area projected and year. Now what you can notice is that the PER demand is rated towards the treated floor area, whereas the renewable energy generation is referenced towards the projected area of the building. And here is why. In this example, we have a one single family house and a multi-story building. Both buildings have a projected area, meaning the piece of land that they are using. This projected area is the same, roughly, for both buildings. It's shown with the red line. But you can see that the multi-story house will have a much higher treated floor area than the single family one. So now, if you are assuming that both houses have a similar energy efficiency level and that both houses have their roof 100% covered with PV, in the net zero approach, we'll consider that the single family house is a net zero, but that the multi-story house failed. And this is not really fair from our point of view, because both buildings have made the most of the land that was available to them. And also, compact multi-story building is making a better use of the resource and the land that it has. This is why we are considering the energy they are generating towards the area they are using, not towards the treated floor area. So here an example. Maybe you already know this building. It's in Austria and it has a very low heating demand. It's heated by pellets. Now if you want to make out of this building a plus passive house, we would need to complete all the south-oriented roof with PV. We don't need to make it more efficient, because with its current efficiency it is already complying the criteria of the Passive House Plus. But if we want now to make out of this building a Passive House Premium, then we would need to increase its efficiency. For instance, by replacing the wood log heating through a heat pump that would take its electricity from the renewable energy generation. We would also need more renewable energy generation, and we could then, for instance, buy a wind turbine nearby. So basically, it's really important that energy efficiency come first, because storage losses need to be taken into account, especially for the renewable energy generation. And that is why we encourage you to go for the Passive House standard and the NFIT standard for retrofitting. Now I'm coming to the PHPP, which is the calculation tool for passive houses. So briefly, it is a design and optimization tool that is made of a series of Excel spreadsheets, and that is working for all buildings internationally, for low energy buildings such as passive house and NFIT retrofits. And it has validated accuracy of results, because we are always developing it according to monitoring results and to our research. It's currently available in those countries and in several languages as well, and it will be soon available in Portuguese. Now, what is new in PHPP 9? So, as I've already presented the PER factors and the passive house classes verification, another thing that is new is the international climate zones and NFIT criteria. And what most people are usually looking forward to, it's the variant and cost comparison sheet. There are also new helpful tools such as input assistance and error messages, and some more extensions. Now, just to show you quickly that passive house stays passive house, this is how the result sheets look like. It's quite similar to the one in PHPP 8, except that there are now two new lines for the PER factors. We will still consider the verification method through PE factors for a transition time. That's why they are still available on the result sheet. Regarding the international component criteria, we have now divided the world into several climate zones, and we have issued for each climate zones which quality of components we are waiting for NFIT buildings. That's to say that now you can verify if you can apply for certification for your NFIT project according to the quality of building components based on those climate zone requirements. So now to the variant calculation. So it's a great tool because it enables you to calculate several variants into just one PHPP. Like, for instance, if you want to see if by adding more insulation or by having less insulation, your building would still be a passive house. It's also great for retrofit because you can enter in the same PHPP your existing building as well as your retrofitted building and all the steps in between. And And this helps you to gain time, to gain storage capacity, and to avoid some errors from jumping to one PHPP to another, because in the past you would have needed one PHPP per step. And it's also great to calculate similar houses, like row houses. Now, how it looks like. You can see there is an active variant, which is displayed in the PHPP. And on the right of this active variant, you can enter up to 99 variants. And you will see the results display immediately on the top of this variant sheet, so that you can quickly compare which variant is the most performing one. And in the input variable section, you can enter several parameters, such as the layer of a wall, another ventilation unit, or even user-defined parameter, like for instance climate. Like one of our colleagues used this variant sheet to make a study of a passive house in different climate zones in China. So he just had to make one PHPP for his passive house, and then to enter as a varying parameter the climate, so he would have all the results in one PHPP of his passive house in different climates, instead of having 20 different PHPP for the same house. And the other sheet that is really important is the cost-effectiveness comparison. There you can compare two variants. You can enter the life cycle cost, the investment, if you had some fundings, and the life of the component, lifespan of the component. So it's really a helpful tool, because you can now quickly show to your client why he should go when retrofitting his building for insulation instead of just painting a new facade. Because as you can see, it may be more expensive at the beginning, but over the observation period he has chosen, it will pay off. Like you see in red, the operation cost for better thermal protection are much lower. And this is also the systematic layout and input assistance. These are some tools that are helping you to come around PHPP, like they're giving you error messages now and input advices. There is also a new section, plausibility advice, to check if your results are plausible in the PHPP. And we also have components recommendation, according to the climate you will be choosing. Moreover, there is the window traffic light, which is showing you if with the window you have chosen, the comfort criteria are met. And now I'm going to Design PH, which is the graphic interface of PHPP. So basically, Design PH is a plugin for the 3D design software SketchUp. It was made to optimize the geometry input and to simplify the optimization of passive houses. So how it's working, you design the passive house project in 3D in SketchUp, and then you export it to PHPP. It's a useful tool for both simple and complex design, and it's also great to communicate with your client. There are two main ways to use it. Like you can design your building in SketchUp and make a quick analysis by using the default specification, export it to PHPP where you will make the further refinements. But you could also use a more iterative design process. That's to say, design your project in SketchUp and make several analyses and refinements in SketchUp, because in SketchUp you can change the U values, you can also add the shading objects and calculate the treated floor area, for instance. And then you export it to PHPP. So all I can say is let Design PH do the work for you. There is a free trial that you can test on designph.org, and there are versions available for educational purposes and for professional purposes. And quickly to finish with, we'd like to invite you to our 20th International Passive House Conference, which will be in Darmstadt, and when we will be celebrating the 25 years of Passive House. The focus of this year's component award will be on cost-efficient ventilation for refurbishment. You can still submit your entry until the end of the year. And of course, you're very welcome to participate in the Passive House Days. It's a great opportunity to visit passive houses and to take part to interesting talks. So I'm looking forward to meet you at one of those events, and thank you very much for your attention.
Okay, so we will have time for questions. First of all, thank you for your interesting presentation. And let me know if there is any question. No? May I do just 2 short questions? The first one is if Germany has already the definition of nearly zero energy building. Because we have assumed that Portugal doesn't have it, so do you know?
I know that it is being fostered in some region of Germany, but I'm not sure if they have already fixed their definition for nearly zero energy building for the whole country.
And the second question is related with the renewables. If you may consider the energy that you are selling to the grid, to the verification of your requirements, if you may count with that energy.
Basically, the energy that you are generating, we're considering that you are giving it into the grid. We're not reducing the amount of energy you're generating from your heating and cooling demand. And we consider that it has a PR factor of 1.
Thank you. I give you again the opportunity to ask something to Arquiteto João or to Camille. No questions? Por mim pode. Só
Queres fazer a pergunta em inglês? Pode ser, é para ambos. Ouve-se?
Thank you. Well, it's a bit technical question, but I think it's the place to make it. Well, very long ago I visited several passive houses in Germany, in Freiburg and Hanover, these very well-known neighborhoods. Well, this standard of passive houses had always a problem of being completely unsuitable for our country because we have really very low energy requirements for heating and cooling compared with German ones because of this winter. And so you now shown the Mediterranean areas of the passive standard, and I was curious because I could not understand it. This reference value of 15 kilowatts per hour was always very surprising for me because I was studying this in Portugal when I visited, and in Lisbon you have nice houses that have the requirement of 4. So a passive house of 15 was for us not a really very relevant thing. And this has been always a very deep problem on the understanding of these matters in Portugal, even in political levels, because we will never spend so much energy as Germans, and I also lived in Germany, in energy in the building sector. And even also, if we speak about emissions, what is really, really important are nowadays the emissions of mobility, if we really want to make the things different. Okay, buildings have also a contribution. But what I really wanted to ask is, after all, which is now the standard value for to consider passive house in our climate area? Which is the value taken for the minimum, the maximum requirements in kilowatt hour per square meter? Did I was clear?
The 15 kilowatt hour and the alternative criteria of 10 watt per square meter and year and are valid for worldwide.
But if you have houses in Lisbon that are not passive, that were houses built by normal people, well, without having this concern, but that are good orientated, this is enough. If by chance the house is, or by chance not, or by purpose, the house is good orientated, the requirements are of 4. You understand? Not of 15, neither of 10.
By HPP or by the national calculation?
Yeah.
Well, this is a study that is available since 2002 by INETI that made evaluation of several houses in Lisbon, in several parts of Lisbon, and it was concluded that the average was very low. I remember of several examples of 4. That's why.
But for heating and cooling?
Exactly. Because we are in a tradition of climatization that is completely different from yours. Many families in Lisbon. I live in Lisbon. That's also a different area on the country. It's quite warm. But people don't turn on the heating so often. They simply wear a sweater, or they use the windows, or because it's never so cold like in
But
other
then it's a
countries
question
in
of
Europe.
comfort as well, because with the Passivhaus standard you have much more comfort.
This is relative. Well, this is another discussion.
Because you have less draft as well?
Well, it depends of the habits of ventilation also. But could you answer to my question? Is how much is the standard now? Because
Still the same.
it's 15.
15.
I mean, if I only have a passive house, if I have it
No,
less than
because
50.
there are other criteria to look
Yeah,
at,
and
like the
there are-
airtightness as well.
But
And
this reference is the same for all the climate areas.
I think we need to go on, which means that in Portugal it's easier to reach the requirements.
Não, porque os requirements are not,
But
neste
so
caso é um
which-
requerimento que está desadequado.
Which
Se uma
means-
casa tem 4, por que está a fazer um requerimento de 15?
Maybe I can give you also an answer. You are in a much more lucky climate than we in the Central Europe, yeah? So that's a good information for you, yeah? But I'm sure your 4 kilowatt hours are not 4 kilowatt hours if you calculate it by BHPP. You give the answer, that was calculated by the national norm program, yes? And I can tell you also in Austria and all over the world, in all national norm calculations, there is a big performance gap of 100, 200 or 300%. So the difference between the real consumption and that's what the norm calculation says, the energy passport is a big difference that has nothing to do with the reality. The other thing is that many people in Portugal don't heat because they have no money. So you have, for heating, you have a temperature inside from 18 degrees, and I'm sure it's not really very comfortable. So the norm calculation everywhere is by 20 degrees, and then the criteria is this 15 kilowatt hours for heating and cooling. And you use a lot of cooling for electricity that you have, so that is the higher point.
Thank you. I don't know if Camille want to say something,
Yeah,
but
I just
just a
want-
brief comment.
Yeah, to say that this 15 kilowatt hour were with a temperature of 20 degrees, also, like Gunther said.